So when you work with statistical data sets, you always come across instances where the data has NA values, so or else they're not available. Maybe because sensor did not work properly and they forget to forget to record a certain record, or maybe another reason is that a human blunder. Likewise, so in these occasions we have to work various ways to replace these values. So when you are working, even though this is not completely related to the subject contents that we are going to talk in here, so before I start any coding, I just like to teach you how we can use various techniques to replace these values in datasets. So for this example, I am going to use a built-in datasets in RStudio. So you can see all the datasets available in RStudio, and running this code data 2 brackets. Then when you run the program, you will see all the freely available datasets in the RStudio. So you can see air passengers information, monthly airline passenger numbers, BJ sales data with leading indicators. Likewise, so likewise there are many datasets available for your reference. So for this example, I will just select this air quality dataset, New York air quality measurements. So if you want to view a dataset, you just have to write like this, and so in this way you can get the datasets available, import datasets to RStudio. So we'll run this program, and then it will come to as import as a value. So if you want to view this data like we previously did, you can just write a table head function. So for this, before we do that, we will just get some information about this data set. We'll run this chunk of code again. So you can see there are various information like there are various 153 observations, and it has 6 variables available, and most of the data sets are integer values. However, there is another num value also, and there in here in the summary you can get the minimum and maximum values. So another important thing I should mention is that in here you can see there are under ozone there are 37 NA values. So if you run the program with including these NA values, it will give you erroneous results when calculating mean values, including like that. So in here solar radiation, it has not available values, 7 not available values. So in this lecture series, in this particular video, I am going to introduce you 4 methods that we can replace these NA values. So first of all, the first method is that we can remove all these NA values pertaining to the entire rows. So the first method is that we can actually remove the entire row if there is a NA value for that. So we can just write so in this way we can find not available values, and we can call the OMI function, and then it will remove all the rows which have NA values. So we'll again we can get this information here, and then you will see so problem is that I have misspelled here, and we'll run again. So now you can see here, in here there is only 111 observations of 6 variables, so which means that there was previously 153 observations. So what happened is that all the data containing NA values or not available values, the RStudio have deleted the entire row. So for more information, if you click on this AQ table, you can see that after the 4th row it comes 7, which means that 5th and 6th rows have been deleted from the system. So it is one method that we can use to delete the not available values. However, the problem is that there are certain instances that majority of the datasets may have NA values or not available values. In these occasions, sometimes the more than half of the data rows may be removed from the system or from the dataset. So in these occasions, the accuracy and the data will also reduce. The number of data also reduce, because sometimes even though the data is not available, for the analysis we may not require that data. So in these occasions, replacing the NA value is not the correct way or not the most suitable or the ideal method. So one method is the second method is that we can remove or replace the NA values with 0, number 0. So we can do that. So I'll create a variable turn 0 and then assign the original dataset to here, and then we can write this function So in this way we can assign all the not available values to 0, and then we can print this information again. So let's run the program again. So now you can see the number of datasets is still 153 with 6 variables. However, you can't see any not available values. For an example, when you open this table, last time we haven't seen the number 5 and number 6 rows, right? So in this way, in this time, row number 5 is replaced by 0. The ozone value of row number 5 replaced with 0, which previously was NA or not available. So that is another method that we can use to replace NA values, deal with the NA values. But some may not recommend this method, because when you are calculating the mean values, the mean may be changed really drastically. Mean values could be changed drastically. So rather than turning it 0, the best method is to, sometimes many statisticians suggest is that you can use the mean values. So in the third method, I am going to show you how you can replace these not available values by mean values of the entire dataset, because sometimes occasionally there may be instances that the user or the sensor miss the recording that certain so now let's see how we can deal with not available values with mean values. So the first step is that we have to calculate the mean of the ozone layer without the Na value. So we can calculate it by specifying we have to select the air quality table, and in here we have to select the ozone column, and then we are specifying the Na dot Rm equals T. So in this way it automatically the system RStudio calculates the mean ozone value for the data sets using this mean function. So the next step is to replace the not available values with this calculated mean value. So this can be done by with an if else statement, and we are specifying the RStudio that if there is an value with a not available value, you have to replace it with the mean value of the calculated mean value of ozone. So we can do that by, let's say, the mean fix. We have to specify the column, and then so now we specify the which value to be used to replace, and finally the column to be replaced, and we'll again get the output pertaining to this factor mean fix table. There's a small error here, let's see. So the problem is that there is a syntax error here. So now it should work. So now values have been changed. So in order to compare with the previous results, we can compare the current results with the original dataset results. So we can do that by getting a summary of the original dataset pertaining to the ozone column. So let's run this code. So now you can see after replacing the values, some of the datasets have been changed, like first quadrant value is 21, first quadrant value is in here 18. So in here there are 37 not available values. However, after fixing with mean values, you can't see any not available values. However, it is obvious the mean value is not changed because you are replacing the mean value with the mean value of the original dataset. So this is another method that you can deal with the not available datasets. So there is another method of dealing with not available values. It is called predictive mean mapping. However, the predictive mean mapping method is quite complex to understand than the first three methods. However, it is not a requirement to understand how it happens, because it is not directly related to what we are doing in this course. So if you don't understand, or if you can't follow what I am explaining, it doesn't matter. You just have to use that method to when you are deal with the not available values in RStudio datasets. So first of all, what you have to do is that you have to visualize the not available patterns, not available data patterns. So for that, you have to import two libraries, because we are going to use these libraries in the later part of this method. So we'll get a copy of the original dataset, predictive mean mapping, air quality. So we have to, in order to visualize this, there is a chunk of code we have to use. So I'll just copy and paste, because I have already wrote it in Notepad in order to save time. So before we go to the next part, we'll just visualize this. So now you can correctly see the pattern of the missing data, how it is aligned, and then you can see the variations of the data sets from here. So the next step is to conduct the predictive mean mapping process. So in here you can see I have added the number of I have added the data set here, and then we have to specify the number of data set. Here I am using the default parameters for this. So likewise we can specify the method also, like predictive mean mapping method. There are other methods also. However, we are usually use this method more widely, and we can get the summary data set. And finally we can inject the mean values. So it might take some time to run the predictive mean mapping process, and there's a small error. So now you can see that these are the rows that was missing data. So you can see it has been replaced with the new values here. So before I wind up this long video, I just want to specify that this chunk of code is actually not necessary to run the predictive mean mapping. This is actually necessary only to visualize how our not available data are arranged in our dataset. So in here I'll repeat again what we have done here. So in here we have initiated the predictive mean mapping process, and we get the summary report of that, and finally after getting that summary report, we updated the ozone, we update or imputed in terms of RStudio, we imputed PMF updated values into the ozone column. So see you in the next video.